So we are given this question to check whether the function is continuous or not. We are going to test its continuity. So the function is 4x minus 1. When x is greater than 1, then we are going to use this one. If x is less than 1, then we are going to use this one. It means if we draw a line, just for understanding, and here we have x equals to 1, and this is the region when x is greater than 1, and this is the region when x is less than 1. So we can define the regions into different parts. You can see when x is equal or greater than 1, you can use 4x minus 1. So it means for this region, f of x is x minus 1. And for this region, minus x squared plus x plus 3. So now we have defined our two regions where x is 1 and it greater than 1, then it would be the right hand side, and when it is less than 1, we can define it like this. So for continuity, first we will check whether f of, the first thing is to check f of a is defined or not. So this is the first condition to check continuity. So here you can see we have x equal to 1. So f of 1 is defined or undefined. So we can put in any of them. We are getting defined values. We are going like 4 times 1 is 4, minus 1 is 3. So you can write f of 1 is equal to 3. So it's a defined value. So first condition is satisfied. We are going to move to second condition to check whether limit x approaches to a like this is our, we are going to check whether this limit is going to exist or not. So in order to check whether the limit exists or not, we are going to apply limit on it. So in order to check whether the limit exists or not, we are going to approach this function from both sides. This is one part of the function. This is the second part of the function. So we will approach it from the left hand side and the right hand side. We know this. This is the function which is, you can say, on the right hand side. This is on the left hand side. So we are going to apply left hand limit and right hand limit on it. So left hand limit, I just wrote it. So this minus represents the left hand limit. This plus here represents that we are approaching it from the right hand side. So the value remains 1. It makes no difference, but it represents that we are approaching the function from each side. So if we insert 1 in it, it would become 1 square plus 1 plus 3. So 1 and 1 are cancelled. We have 3. And if we insert 1 in it, function is gives 3. So it means left hand limit and right hand limit are equal, which means limit exists. So our second condition is also satisfied. Third condition is limit x approaches to 1, f of x should be equal to f of a or f of 1. So it means when x equal to 1. X equal to 1, you can see when x equal to 1 and x is greater than 1, we have this function. So we can use this one. So it is 4x minus 1. And if we replace x with 1, so you can see limit x approaches to 1 f of x and f of 1 both are equal. So this function is continuous because it satisfied all values. Oh, sorry, all conditions. So that's why we are going to consider this function as a continuous function.